In many homes, water access is treated as background infrastructure. A faucet turns and water appears. Showers, cooking, cleaning, and outdoor use all depend on that steady flow. Most of the time, attention stays on other parts of daily life, not on the systems that make water available. Extra effort usually becomes visible when that flow is interrupted or feels uncertain. People begin tracking how much water is stored. Containers get filled and rotated. Filters are checked. Trips may be made to pick up bottled water or additional supplies. Even simple tasks start to involve planning. How much to use, when to refill, where to store it. Traditional approaches to securing water outside of standard plumbing often involve visible labor. Wells require drilling, equipment, and maintenance. Rain collection depends on weather patterns, roof surfaces, and storage capacity. Transporting water from external sources involves lifting, carrying, and vehicle use. Each method works within limits set by location, climate, and available equipment. Over time, the effort is not always dramatic, but it repeats. Checking levels, cleaning containers, managing storage space, watching usage during dry periods. The weight comes from these small, recurring tasks rather than from a single large job. Joseph's Well is presented as a digital instructional package. Its format centers on step-by-step building guidance rather than on a finished physical device shipped to the user. The core materials typically include written instructions, diagrams or blueprints, and video demonstrations. These elements are organized to show how a water-generating setup can be assembled using commonly available components. The focus of the package is on the construction process and system layout. Delivery happens digitally. Access is provided online, where the instructional content can be viewed, downloaded, or referenced during the build process. Nothing physical arrives by mail as part of the base format. The user sources parts independently. The conceptual purpose of the material is to document how a small-scale atmospheric water collection system can be assembled. In structural terms, it functions more like a technical guide or DIY manual than like a service, subscription, or installed appliance. Use begins at a planning stage. A person reviews the materials list, checks which components are already available, and identifies what needs to be purchased. Time is spent reading instructions and watching demonstrations before any assembly starts. The build process itself involves hands-on work. Parts are arranged, connected, and housed according to the guide. This may happen in a garage, shed, workshop corner, or outdoor space, where tools and materials can be spread out. The pace depends on the builder's schedule and familiarity with basic mechanical or electrical tasks. Once assembled, the system operates more like a small appliance than like an ongoing project. It is placed in a location with suitable airflow and power access. Operation involves switching it on, monitoring collection containers, and performing periodic checks. Ongoing interaction is lower than during the build phase but does not drop to zero. Filters, surfaces, and internal components may need occasional cleaning. Water collected must be transferred, stored, or used. Power sources, whether grid-based or alternative, require their own basic oversight. In daily life, this looks like a device running in the background while other tasks happen. A container is checked, emptied, or replaced. A quick inspection is done to confirm normal operation. Most of the time, attention returns to other household routines. This format aligns with people who are comfortable working from instructions rather than purchasing a ready-made machine. They tend to accept a build phase that takes time and effort up front in exchange for having control over the setup. It also suits those who prefer contained systems with clear boundaries. The guide focuses on one defined function and does not expand into a broad, multi-topic program. Someone who likes step-by-step processes and finite projects may find this structure familiar. People who already use tools for home projects, repairs, or small constructions may find the format closer to what they have done before. They are used to gathering materials, following diagrams, and adjusting components as needed. On the other hand, those who want a plug-and-play solution with no assembly may find the process too involved. The format does not remove the need to source parts, handle tools, or allocate workspace. It also does not function as an automated service or maintenance-free system. Compared to professionally manufactured water systems, this format shifts more responsibility to the user. Commercial units often arrive pre-assembled, with integrated housings and standardized parts. Here, assembly and part selection are part of the experience. Compared to purely passive solutions like stored bottled water, the guide represents a more active approach. Instead of purchasing and stacking finished water, the effort goes into building and operating a device that produces water over time. In contrast to complex infrastructure projects such as drilling wells or installing large-scale collection systems, the scale is smaller and more localized. The physical footprint and equipment demands are typically closer to those of a compact appliance than to major construction. On the effort spectrum, the format sits between simple storage and large installations. It reduces some forms of heavy construction, but replaces them with hands-on assembly and ongoing light maintenance. Depth and customization come from how the system is built and adjusted, while simplicity appears in its narrow functional focus and contained scope.